Welcome to Unacademy. Let us crack GATE, ME and CE. This is K. Mameshwarao. Unacademy is announcing flat 25% off plus free month subscriptions. Join foundation batches for GATE ESE PSUs 2024 starting from 16th June. Flat 25% off plus free month subscription. Use code KUR75. Offer is valid till 17th June. Unacademy is congratulating GATE 2023 top rankers. Unacademy is announcing foundation batch. One batch for GATE ESE PSUs 2024. Batch commences from June 16th. Crack GATE XE with the top indicators: engineering mathematics, fluid mechanics, solid mechanics, thermodynamics and general aptitude. Crack GATE XE. Crack GATE XE with the best course repository starting at 656 rupees per month. ISRO Scientists 2023 test series in computer science and engineering, mechanical engineering and electronics and communication engineering. Subscription price is 299 rupees. Unacademy Center for GATE. New offline batch starts from June 19th. Admissions are open. Avail existing discounts. Contact 8585 Call now or schedule a call back. Welcome to the Foundation Engineering Mathematics, Probability and Statistics. A die is rolled 3 times. What is the probability that exactly one odd number will turns up? A die is rolled 3 times. What is the chance that exactly one odd number? Number of trials are 3. X counts. Number of odd numbers. P is probability of getting odd number 3 by 6. 1 by 2. Q is 1 minus 1 by 2, that is 1 by 2. We have to calculate probability of exactly getting one odd number. NC1 P power 1 Q power n minus 1 3C1 1 by 2 whole power 1 1 by 2 whole power 3 minus 1, that is nothing but 3 by 8. The required probability is 3 by 8. In a manufacturing plant, probability of making a defective bolt is 0.1. The mean and standard deviation of a total of 900 bolts respectively. So here n value 900. Probability P is 0.1. Therefore Q is 0.9. Problem is designed on mean and standard deviation. Binomial mean is given by NP. N value 900. P value 0.1. Therefore 90. Binomial variance is NPQ. 900 into 0.1 into 0.9, that is 81. Standard deviation is square root of variance. Square root of 81, that is 9. Mean is 90, standard deviation is 9. So 90 and 9 is the correct answers. Mean 90, standard deviation 9. Four coins are tossed simultaneously. What is the probability that at least one head and at least one tail turns up? At least one head and at least one tail turns up. Do one thing. No tails, and here we have to calculate at least one head and at least one tail. At least one tail and at least one head. See here, you should not get all tails or all heads. You must get at least one head and at least one tail. Remaining all cases you will get at least one head and at least one tail. So these two cases are ruled out. That's why the required probability is 1 minus 2 by 16, that is 14 by 16. 7 by 8 is the required probability. Understood? 7 by 8 is the required probability. Should not get all tails or all heads. In remaining all cases you will get at least one head and at least one tail. A coin is tossed 4 times. What is the probability that 2 heads and 2 tails ruled out, 2 tails will result? 2 heads and 2 tails. How many times coin is tossed? 4 times. You have to get exactly 2 heads and exactly 2 tails. Try this one. A coin is tossed 4 times. Suppose P is probability of getting head 1 by 2. Probability of getting tail is 1 by 2. X counts number of heads. You have to calculate. Probability of number of heads are 2. Number of heads are 2 means automatically number of tails are also 2. NC2 P power 2 Q power n minus 2. 4C2 1 by 2 whole square. 1 by 2 whole power 4 minus 2 is 2. 4C2 is 6. 1 by 2 whole power 4 is 16. 6 by 16 is 3 by 8. The required probability is 3 by 8. A lot had 10 defective items. 10 defective items. 10% of defective items. 10 items are selected at random from this lot. What is the probability that exactly 2 of them are defective? See here, n value 10. X counts number of defectives. Probability of defective is 10%. P is 10%. Q is 90%. Probability that exactly 2 of them are defective. NC2 P power 2 Q power n minus 2. C2 into 0.10 whole square into 0.90 whole power 8 is the answer. A coin is tossed. A coin is tossed 4 times. What is the probability that? What is probability of getting heads? Exactly 3 times. Probability of getting head exactly 3 times. A coin is tossed 4 times. N value 4. X counts number of heads. P is probability of getting head. QE is 1 by 2. we have to calculate probability of getting exactly heads 3 times. NC3 P power 3 Q power n minus 3 4C3 1 by 2 whole power 3 1 by 2 whole power 4 minus 3 4C3 is 4 2 power 4 is 16 final answer is 1 by 4 that is 0.25 3 coins are tossed simultaneously. The probability of getting at least one head. 3 coins are tossed simultaneously. Probability of getting at least one head. Observe here. When 3 coins are tossed simultaneously, probability of getting at least one head means you should not consider TTT. So remaining 7 cases, the required probability is 7 by 8. A coin is tossed independently 4 times. The probability of the event, the number of times heads shows up, is more than the number of times tails shows up. Number of heads are more than number of tails. Observe, number of heads are more than number of tails means here a coin is tossed 4 times, n value 4, x counts number of heads, p is probability of getting head, q is probability of getting tail. Now here number of heads are more than number of tails means number of heads are 3, number of tails are 1, or number of heads are 4, number of tails are 0. These 2 cases we have to calculate. Probability that number of heads are more than number of tails means, so probability of x equal to 3, or probability of x equal to 4. NC3 p power 3 q power n minus 3 plus NC4 p power 4 q power n minus 4, n value 4, 4C3 1 by 2 whole power 3, 1 by 2 whole power 1, 4C4 1 by 2 whole power 4, 1 by 2 whole power 0, that is 1 by 2 whole power 4 of 4C3 plus 4C4 1 by 16 of 4 plus 1. Final answer is 5 by 16. Final answer is 5 by 16. An unbiased coin is tossed 5 times. The outcome of each loss is either head or tail. What is probability of getting at least one head? At least one head. A coin is tossed 5 times. What is chance of getting at least one head? (31 by 32 is the answer. 31 by 32 is the answer. The reason is, if a coin is tossed 5 times, total number of possible outcomes are 32. Yes, questioned at least one head. So all tails case you should not consider. If you should not consider all tails case, so favorable cases are 31. Favorable cases of at least one head (31). Therefore, required probability is 31 by 32. Required probability is 31 by 32. In an experiment, positive and negative values are equally likely to occur. What is probability of getting at most one negative value? At most one negative value in 5 trials. Try this one. At most one negative value. Observe here, n value 5, x counts number of negative values. Next, we have to calculate probability of getting negative value is 1 by 2, probability of getting positive value is also 1 by 2. We have to calculate probability of x less than or equal to 1, either no negative value or 1 negative value. NC0 p power 0 q power n minus 0 plus NC1 p power 1 q power n minus 1. So here 1 by 2 whole power 5 plus 5c 1 into 1 by 2 whole power 1 into 1 by 2 whole power 4, 1 by 32 of 1 plus 5, that is 6 by 32. Correct answer is 6 by 32. Next problem. An unbiased coin is tossed infinite number of times. What is the chance that fourth head appears at the 10th toss is? Fourth head appears at the 10th toss. Observe here, fourth head appears at the 10th toss. Exactly 9 trials, we have to get 3 heads. In 9 trials, we have to get exactly 3 heads. And 10th trial, you have to get 1 head. So NC3 p power 3 q power n minus 3 and 1 head in 10th trial. 9C3 1 by 2 whole power 3 into 1 by 2 whole power 9 minus 3 and means multiplication, 1 head 1 by 2, that is 9C3 by 2 power 10 84 by 1024, that is 0.082. Final answer is 0.082. Let x be a random variable satisfying Poisson distribution with mean 2, then probability of x greater than 2 is. Then probability of x greater than 2 is. Good afternoon, Sanjit. A random variable x satisfying Poisson distribution with mean value 2, lambda equal to 2. We have to calculate probability of x greater than 2. In Poisson distribution, to calculate probability of x greater than 2, it is better to calculate probability of 1 minus probability of x less than or equal to 2. Probability of x equal to 0, x equal to 1, x equal to 2. 1 minus e power minus lambda into lambda power 0 by 0 factorial, e power minus lambda into lambda power 1 by 1 factorial, e power minus lambda into lambda square by 2 factorial. That is 1 minus e power minus lambda of 1 plus lambda square by 2, 1 minus e power minus 2 of 1 plus 2 plus 4 by 2, 1 minus 5 into e power minus 2, 1 minus 5 by e square, one minus 5 e square is the correct answer. It is estimated that the average number of events during a year are 3. The probability of occurrence of not more than 2 events over a 3-year duration, average number of events during a year are 3, but problem is designed for 2 years. That's why lambda equal to 6. X counts number of events. We have to calculate probability that number of events not more than 2. Not greater than 2. Not greater than 2 means less than or equal to 2. X equal to 0. X equal to 1. X equal to 2. E power minus lambda into lambda power 0 by 0 factorial. E power minus lambda into lambda power 1 by 1 factorial. E power minus lambda into lambda square by 2 factorial. 1 plus lambda square by 2 e power minus 6 of 1 plus 6 plus 36 by 2 25 into e power minus 6. .062 is the answer. Next, suppose P be the number of cars per minute passing through a certain road junction between 5 p.m. to 6 p.m. P has Poisson distribution with mean 3. Then what is the probability that fewer than 3 cars during any given minute in this interval is? In this problem, lambda value 3, because data is given for 1 minute and question is also designed for 1 minute. So lambda value 3, x counts number of cars crossing the point per minute. Now we have to calculate probability of observing fewer than 3 cars, x less than 3. X less than 3 means x equal to 0, x equal to 1, x equal to 2, e power minus lambda into lambda power 0 by 0 factorial e power minus lambda into lambda power 1 by 1 factorial, e power minus lambda into lambda square by 2 factorial. If you take e power minus lambda common, 1 plus lambda square by 2, e power minus 3 of 1 plus 3 plus 9 by 2, 2 4 ja 8, 8 plus 9, 17 by 2 e cube. That's why third option is correct. A traffic office imposes average 5 number of penalties on daily basis on traffic violators. Assume that number of penalties on different days are independent, follows Poisson distribution. What is the probability that there will be less than 4 penalties in a day? So here lambda value 5, probability of x less than 4, x equal to 0, x equal to 1, x equal to 2, x equal to 3. E power minus lambda into lambda power 0 by 0 factorial, e power minus lambda into lambda power 1 by 1 factorial, e power minus lambda into lambda square by 2 factorial, lambda cube by 3 factorial, 1 plus lambda square by 2 plus lambda cube by 6, 1 plus 5 plus 25 by 2 plus 125 by 6. Simplify this, you'll get the answer. An observer counts 240 vehicles per hour at a specific highway location. Assuming that the vehicle arrive at the location is Poissonly distributed, what is the probability of having one vehicle arriving in a 30-second time interval? Question is designed for 30-second time interval. Data is given for 1 hour. That's why 60 minutes, 240 vehicles. So per 1 minute, 4 vehicles. 60 seconds, 4 vehicles. Therefore 30 seconds, 2 vehicles. That's why lambda value 2. That's why lambda equal to 2. That's why I have to take lambda equal to 2. One vehicle arriving. E power minus lambda into lambda power 1 by 1 factorial. Lambda into e power minus lambda. Lambda value 2. 2 into e power minus 2. 2 by e square. Correct answer is 2 by e square. X is uniformly distributed random variable that takes values between 0 and 1. Then the value of expected value of x square will be, what is expected value of x square? Actually it is a problem on expected value of x cube. Observe, if x follows uniform distribution in the interval 0 to 1, probability density function is 1 by 1 minus 0, 1. Now, expectation of x cube is integral 0 to 1 x cube into f of x dx. integral 0 to 1 x cube into 1 dx, that is x power 4 by 4 that is 1 by 4. Correct answer is 1 by 4. A random variable is uniformly distributed in the interval 2 to 10. What is its variance? Its variance will be x takes values in the interval 2 to 10. Now, variance of x is, if x follows uniform distribution, variance of x is given by beta minus alpha whole square by 12, 10 minus 2 whole square by 12, that is 64 by 12, 16 by 3. So variance of x is 16 by 3. First option is correct. Suppose you break a stick of unit length at a point. If you break a stick of unit length at a point chosen uniformly at random, then expected length of the shorter stick. Observe here. If you break a stick of unit length uniformly at random, what is expected length of the shorter stick? The meaning of shorter is here, the stick which part is less than 50% is shorter. Therefore, to decide shorter stick, our reference point is 50%. The length of the stick is less than 50% is treated as shorter. That's why x follows uniform distribution in the interval 0 to half. F of x is 1 by beta minus alpha, 1 by 1 by 2, that is 2. Now we have to calculate expectation of length. Integral 0 to half x into f of x dx. F of x is 2 dx, that is 2 into x square by 2 from 0 to half. 2 to cancel, 1 by 2 whole square, that is 1 by 4. 1 by 4 is 0.25. So correct answer is 0.25. average length of the shorter stick is 0.25. Next problem. Observe, random variable follows Gaussian distribution, then the value of cumulative distribution function at the origin. Cumulative distribution function value at the origin means left side of origin, whatever area you have, that is cumulative distribution function value at the origin. Probability of x less than 0 or less than or equal to 0 is nothing but 0.5. So correct answer is 0.5. Next problem. A random variable x follows normal distribution with mean 100 and probability of x less than or x greater than or equal to 110 is alpha. Then the probability that area between 90 to 110 is. Area between 90 to 110 is. Given that mean is 100, probability of x greater than or equal to 110 is alpha. This is 100. 110 is right side of 100. The area beyond 110 is alpha. That is given in the data. Normal curve is symmetrical about its mean. Suppose if you fold this graph along the mean line, the area beyond 90 is also alpha. The area beyond 110 is alpha, therefore the area beyond 90 is also alpha. When you fold the graph along the mean line, 110 and 90 coincides. That's why we have to calculate area between 90 to 110, this part. Total area under the curve is 1 unit. Beyond 110 is alpha, beyond 90 is alpha. Total area is 1. Therefore, this red color part is 1 minus 2 alpha. Your question is also on that part. Area between 90 to 110, that is 1 minus 2 alpha. Understood? Next problem. Next problem. Observe here. Here mean is 102. Sigma is 27. The probability that annual precipitation between 90 to 102 we have to calculate. Normal curve is symmetrical about its mean. One not 2 minus 27, 1 not 2 plus 27. So the area between 75 to 129 is the area between 75 to 129 is 66.7%. Therefore, the area between 75 to 102 is 33.3%. 75 to 102 mu minus sigma to mu. Half of this, therefore 33.3%. We have to calculate probability of 90 to 102. This area we have to find out. So, probability of 90 less than x less than 102 is not 66%, not 50%, not 33.3%. Therefore, 16.7% is correct. Understood? So, correct answer is 16.7%. Thank you.